Question 41 from the homework is a pretty good question. It's a challenging question. We have to pay attention to a few details and really think about what we know and the calculations we know. And so it says a 2.02 gram sample of a non-electrolyte is dissolved in 54.6 grams of water, and that solution freezes at negative 1.23 degrees Celsius. Calculate the molar mass of that solute. All right, so eventually we have to use our change in freezing point equals negative I, our Van Hoff factor times our freezing point constant for water times the molality, right? They tell us that it's a water solution, so with the freezing point constant of water, right, is the other thing we need. 1.86 degrees Celsius per molal. Taking a look, right, we have a few other pieces of information that we might not have realized. And the key to that is this word right here. Non-electrolyte is dissolved. Right, so in this equation, we actually know our delta TF because it tells us the new freezing point is negative 1.23 degrees Celsius. We know our Van Hoff factor, right, because it's a non-electrolyte, so that equals 1. We know our freezing point constant, 1.86 degrees Celsius per molal. We need to find our molality. So step 1 is simply that. We're going to divide across by negative 1.86 degrees Celsius per molal. And I get the molality of this solution, right, to be about 0.66 molal. And now we can use that to find, right, the molar mass of our unknown, because I know that molal is moles per kilogram, right, of solvent. I have 54.6 grams, so 54.6 grams, and I know that there are 1,000 grams in 1 kilogram, so divide by 1,000, 0.0546 kilograms. So I'm going to multiply this by 0.0546 kilograms over 1 to see that kilograms cancel out, and I'm left with 0.036 moles of my unknown. Now to find my molar mass, right, we know moles equals grams over my molar mass. So I know moles, I've got 0.036 moles, and I know my mass, right, 2.02 grams of that. So we're going to multiply our molar mass and then divide. So we get molar mass equals 2.02 grams over 0.036 moles, right? Divide those, and I get approximately 55.94 grams per mole as the molar mass of this unknown. And again, the key was this word right here, non-electrolyte. By telling us it's a non-electrolyte, we know the Van Hoff factor. They tell us the change in temperature, and we know the freezing point constant of water. We can use all of that to find our unknown, which is molality. Use molality to find moles, and then because we know mass of our solute that we're adding, we can use moles to find the molar mass of that unknown. And again, be careful in this calculation because your mass might be different, your delta T might be different as well.